Now, are you saying next slide machine learning?
Yeah, no, I understand.
Can you run it there?
No,
Okay.
no, I don't have this computer.
We'll tell you next slide.
All right, so hi everybody, my name is Steven. I'm an undergraduate student at the University of Waterloo, and I'll be presenting a work titled Aloha, Artificial Learning of Human Attributes for Dialogue Agents. So this is a work with Professor Jesse Hoey and the Computational Health Informatics Lab at the University of Waterloo, as well as Huawei. So the overall goal of our work is to give chatbots and virtual assistants the ability to imitate and express human emotions and personality. So we approach this in 3 major steps. First of all, we define these human-level attributes based on tropes, which are aspects of fictional characters representative of their profile and identity. This information is collected from a site called TV Tropes, and this information is provided by users, basically viewers of these television shows. We also present a data set called HLA Chat, which contains hundreds of characters along with their HLA and dialogue data. And finally, we present a system called Artificial Learning of Human Attributes, or Aloha, which is able to retrieve character-specific language models. And specifically in this case, we focus on the task of dialogue retrieval. So now I'll touch briefly upon some of the related work in this area. So a lot of prior work models human emotions and personality in a very non-complex way. So at the very bottom, we have, for example, industry chatbots such as Alexa and Google Assistant. So their goal is to just provide an answer to any question you may have. So they're not really trying to, interact or engage with you in any meaningful manner. So on top of this, we have bots that can imitate basic human emotions, such as, a bot that can imitate someone who is angry, sad, happy, or so forth. On top of this, we have identity or persona modeling. So an example would be Facebook's Conv AI 2 challenge, which presented the persona chat dataset. And a level on top of this would be work that tries to model human personality in a very low-dimensional space, such as the Big Five, such as Personage, which models using the extroversion aspect of the Big Five. And so we present human-level attributes and a system called Aloha that can use these to model human personality in a much more specific and detailed manner. So what exactly are human-level attributes? Well, here we can see an example of 4 more broad attributes, such as characters which might be friendly, trustworthy, helpful, or curious. Now, under each of these, you can see some examples of HLAs, or human-level attributes. So for example, on the top left, we have childhood friends, as well as vitriolic best buds. So these HLAs all have very long and detailed descriptions associated with them, showing how they describe these characters in a much more specific and detailed manner than, for example, the broad attributes which you see on the top. So next, we present this data set called HLA Chat in order to train these personality or character-specific dialogue agents. So this data set has hundreds of characters, attributes or HLAs of these characters, as well as thousands of lines of dialogue for each and every one of those characters. And this is what Aloha will be trained upon. So here's just an example for the character Sheldon Cooper from The Big Bang Theory, which is a popular television show. So on the left, you can see some examples of certain HLAs he has. And you can see that he has over 300 HLAs in total, showing how he is a very complex character. Just like humans, we ourselves are extremely complex beings. On the right, you can see some example of some dialogue lines within our data set. So it's basically dialogue of Sheldon talking to another character within the Big Bang Theory. So next, I'll touch briefly upon our system called Aloha. So the overall task of this system is given a target character with an HLA set. We want to recover this character's language style without any dialogue of the character itself provided during training. Now the reason for doing so is because if we provide the character's dialogue itself during training, chances are the model will just learn to memorize the character's dialogue, for example, by matching engrams, rather than actually learning the personality or character-specific language style of that given character. So Aloha has three major components: the character space module, character community module, as well as the language style retrieval module. And I'll get into more detail about those now. So first of all, we have the character space module, whose overall goal is to map all of the characters within our data set onto a space. And here we just have the T-SNE dimensionality reduced visualization of our character space. So you can see that we can effectively group characters which have similar personalities closer together than others. So how exactly do we learn this character space? Well, we use a process called collaborative filtering, which is quite popular in recommender systems. So we have a ground truth matrix P, where each element of the matrix is either 0 or 1, depending on if the character in that row has the specific HLA in that column. And what we try to do is we try to learn an approximation to this matrix. So for every element within the matrix, we attempt to learn a vector for the latent factors for the character in that specific row, as well as a vector for the latent factors of the specific HLA in that column. And the dot product of these two vectors should approximate the ground truth element within that matrix. And the question marks within the matrix are just masked entities, which we use for validation. And the loss function is displayed below. So after we learn this approximated matrix, we can calculate the L2 norm or Euclidean distance between any two rows. And this represents the distance between the characters, which is then mapped onto the character space. Because you can think of every row of this matrix as representing a specific character. So next, we have the character community module. So what this module does is, given a specific character we wish to imitate the language style of, which we call a target character, try to determine a positive set of characters with similar language styles or personalities as the target character, and all other characters are grouped into the negative set of characters, which we define as characters which have language styles or personalities that are further away from the target character. So we use a two-level connection representation approach in order to approach this. So first of all, given the target character, we look at the top 10% closest characters within the character space to this given target character. So that represents the first level. Next, for each of the characters within this first level set, we look at the top 30 closest characters to each of these, and any of those characters within at least 10 of these sets is classified as a positive character, where the value 10 is called the minimum frequency. So in this given example, the image you can see on the slide, that's using a minimum frequency of 2. So you can see the target character at the very center. The first level set is pink, and the second level sets are blue. And we can see that we can determine characters within the positive community, defined as having close language styles compared to the target character. So next, we have the language style retrieval module. So we actually have two variations of this. We have an LSRM BERT as well as a poly LSRM. So the first one is just trained using the BERT bi-ranker, and the second one is trained using the poly encoder. So I'll just be talking about the BERT LSRM. The poly LSRM is trained in a similar manner. So first of all, we have an pre-trained open domain BERT model trained on tons of internet data. What we do next is we train this model on our dialogue dataset using uniform character sampling. So what happens is the 19 negative samples or distractor samples are sampled uniformly across all other characters within our dataset. Next, we fine-tune on this uniform model to produce BERT LSRM using negative character sampling. So the 19 distractor or negative responses are sampled only from the negative set of characters determined in the previous stage. So this way, the ranker is able to learn to avoid the dialogue of characters within the negative set while imitating the dialogue of characters within the positive community. And just in case you don't know how these rankers work, So the BERT by ranker, we use a total of 20 candidate responses. So given an input line of dialogue and 20 candidate responses, it attempts to rank the candidate responses from 1 to 20, depending on what it thinks is the most likely response. And the 19 distractor samples are basically the 19 other responses excluding the ground truth. So in order to evaluate our system, we conduct both an automatic as well as human evaluation. So we use a 5-fold cross-validation approach, specifically focusing on the 5 target characters displayed on the slide. So these are characters which differ greatly in terms of their profile and identity, and they come from a variety of television shows of differing genres. And here's just an example of our evaluation format, specifically for the human evaluation. So you can see that the human is given a character, they're trying to choose a dialogue response in terms of imitating them, as well as an input line of text. And they're given 20 candidate responses, and their task is to choose what they believe is the correct response of that given character. So our automatic evaluation is very similar, but the only difference is our automatic systems actually rank all of the responses from 1 to 20, compared to the human who just chooses what they think is the best response. And you can see that within the candidate responses, we mask out the names of characters, so the humans basically can't cheat by associating the responses with names of characters within the given television series. So here we can just see some average evaluation results. So I'll touch briefly upon our evaluation metrics as well as baselines. So we have a variety of baselines. Displayed are the more important ones, such as the BERT by ranker, polyencoder, as well as the uniform model. And we have our 2 Aloha variations, Aloha BERT and Aloha Poly, as well as human. And we use a variety of different automatic evaluation metrics. Most important are the hits at 1/20 and 5/20. So this is defined as the accuracy in ranking the ground truth response as the first out of the 20 candidate responses, and within the top 5 of the 20 candidate responses, respectively. So we can see here how the 2 Aloha variations outperform all of the baselines and are able to achieve the closest performance to the humans. Also, note that for humans, we only have hits at 1/20 results because their task is to only choose what they believe to be the best response rather than ranking all 20 candidate responses. So now we can see some results of the hits at 1/20 across all 5 evaluation characters. So we can see here that the 2 Aloha variations, again, are able to achieve the closest performance to humans while outperforming all of the baseline models. So what can be done to expand upon our work? Well, first of all, we can model conversations with the multi-turn response approach. So our current approach only focuses on single-turn dialogue. So one example of that is, for example, I say something to you like hi, and you respond back to me. So that's a single turn of dialogue. Whereas multi-turn would be a longer human conversation where 2 individuals would talk back and forth for possibly multiple dialogue lines. Next, we can model the dialogue counterpart. So for now, we only focus on the specific character's dialogue. We don't really care about who they are talking to or the human level attributes of who they are talking to. Next, we can look at HLA-aligned generative models. So as I stated earlier, our current approach focuses on the task of dialogue retrieval. Dialogue generation is another task, which has its own difficulties, such as preserving text fluency and grammaticality. So that's something that can be expanded upon. We can also look at determining human-level attributes, or HLAs, from text. So our current task is to determine text given HLAs, or a target character, and we can try to investigate the opposite of that. Lastly, we can conduct a larger and more extensive human evaluation. So there's another future work that can be incorporated, which is this task called semantic text exchange, which I presented at EMNLP in November. So the task is to correct the semantic content of text. For example, dialogue agent responses using the original text as a template. So the goal is to correct the semantics while preserving its sentiment and fluency. So just as an example, we might have some original text outputted by the dialogue agent, such as, "It's sunny outside, I know it sucks, but you must wear sunscreen even if it's sticky." And let's say the actual weather in reality is rainy. Then we wish to be able to use the original text as a template, while being able to correct the text to fit the semantic context of the replacement entity, to produce something like, "It's rainy outside, I know it sucks, but you should bring an umbrella even if it's cumbersome." So we present a system called Smarty, which combines similarity masking, entity replacement, and text infilling. And one of the ways to expand upon this work is to, rather than just preserve sentiment, try to preserve personality, or HLAs. So in summary, the major challenge that our work attempts to address is to give chatbots and virtual assistants the ability to imitate human emotions and personality. So we do this by defining these human-level attributes based on tropes, which are aspects of fictional characters representative of the profile and identity, and they are extremely detailed and specific. Next, we present this data set called HLA Chat, containing hundreds of characters along with their HLAs and dialogue data. And lastly, we present a 3-stage system called Artificial Learning of Human Attributes, or ALOHA, which is able to learn to retrieve these character or personality-specific language styles. We show that ALOHA is able to effectively use HLAs to retrieve these character-specific language styles, and that it is robust regardless of the character's identity and profile, the genre of the television show they are from, as well as the input text. So that concludes my presentation. Thank you very much for coming and listening. So I've listed some of the contact information of myself as well as my co-authors. So if you have any questions, you can get in touch with us. I will also be presenting a poster tonight with my co-author Julia. So feel free to come there and ask us any questions you may have as well. Also, we released the data as well as code on GitHub. And also on the right, you can see some interaction examples of humans talking to ALOHA, and the responses of ALOHA in trying to imitate the 3 characters of Sheldon, Picard, and Marge. And last but not least, I just wish to say that I'm currently applying for PhD positions. Thank you.